Welcome everyone that's jumping on. Great to have you. Thanks very much. This is the August Power BI and Data Analytics for Enviro session. And to all those people that are new, welcome for the first time. For some of our regulars, thanks again for jumping back on. Today's session is going to be fantastic, very interesting. We'll cover not just Power BI, but touch on a whole range of, the workflow that was put together for what was such, a large-scale construction project out of Melbourne, Victoria, the Westgate Tunnel project. So for those people that are new, in terms of our mission, in terms of this meetup, what we are aiming for is really to help share case studies, mainly focused on the environmental and the water industry, allow our audience members to learn new tips and tricks and also possibilities of what you can do in Power BI, and really just to help Enviros on their Power BI journey, whatever stage you may be at. Just basic sort of housekeeping. As a courtesy to the presenters, just please mute yourself when not speaking and during the presentation. Feel free to type any questions that you have in the chat. We'll do our best to answer them in the chat directly, or there will be an opportunity to ask these questions direct of our presenters. I've just hit the recording button so I can see that's going, and this recording will be shared afterwards on our YouTube channel and also through the meetup group. Just acknowledgement of country. So Alice and I, part of the Discovery I team, we're based out of Perth now. So I'd just like to acknowledge the Whadjuk people of the Noongar Nation, traditional owners of the greater Fremantle / Walyallup area, where we are dialing in from, and pay our respects to their elders past and present. Just a little photo of, if anyone's been to Perth or Fremantle, Rottnest Island, highly recommend it. Great little tourist destination. This is a little photo off the Perth coast. But yeah, just like to pay our respects to the traditional owners here, and also the traditional owners from wherever you're dialing in from yourself, whether that's within Australia or globally across the Indigenous communities. Discovery Eye, we put on these meetup every month, or try and get it up every month. Sort of work that we focus on is Power BI training, report design, looking at end-to-end report development. We really focus on the design elements. So we also develop, infographics and animations for communication-based purposes, and just general environmental analytics. But onto the main session, which is why everyone has dialed in. Really excited and appreciative and privileged to be able to have Rowan, Matt, and Amrit from the Agile Analytics team presenting today on the Westgate Tunnel. So it's titled the Cradle to Grave Power BI Reporting Solution. Guys, I'll let you do your own introduction of yourselves when you get started if you want. But yeah, just in brief, Matt, CEO of Agile Analytics, Amrit, who's the main project manager of the Westgate Tunnel project, and Rowan, who's a senior Power BI consultant who worked on development of the reports. But the session today, we're looking at large-scale construction project, the Westgate Tunnel, and how data was managed in relation to spoil management across the whole workflow. So the project provided an opportunity to develop a centralised data management system and near real-time reporting solution to monitor and track this movement of excavated soil from the tunnelling process. So today's presentation will focus on the operational reporting solution, really ticking off three main items, or looking to address three main items. So how key business problems can be solved through this near real-time reporting, how key stakeholders can make informed decisions to run successful operations, and how time and money can be saved when this information is available at hand and decisions can be made, which at the end of the day, based on communicating the data that we're all collecting and that we have, is really what it's all about. How can we make these educated and informed decisions? So without further ado, I think, Matt, you will talk first. Is that correct?
Yeah, please.
Mate, I'll stop sharing and I'll pass it on to you to get started with the main part of our presentation. So thanks again, guys. I'm really looking forward to this one.
Beautiful. Thanks, Christian. So I think just very quickly about me, obviously, Christian's already introduced me, CEO of Agile. I've been with this business for about 2.5, 3 years. So I joined at kind of the midway point of when the business was started. And now, we've got basically teams across most of Australia, with the exception of WA, I should say. And we've got a center in the Philippines, as well as another one in India as well. And predominantly we focus on basically analytics, data, and automation kind of use cases, and all on the Microsoft stack. So obviously our reporting solution was actually built on Power BI as well. And so I think maybe before we get into the kind of nuts and bolts of it, and Emery kind of takes it from there, we were actually introduced to the stakeholders that wanted to basically build this solution through Christian and Alice. So basically, they had an initial kind of view on how some of these data points should be kind of captured and collected and then reported. But the project actually probably had its kind of starting point or inception several years before we actually, all of us got involved. And it actually was born out of the fact that there was some contaminated soil that was actually identified as part of kind of the work around the excavation machines and the sampling that the construction companies kind of did through that process. So that identified that there was some issues, obviously, with requirements around how soil and spoil needed to kind of be excavated, how it needed to be kind of tested and sampled, and then obviously where it actually ended up and how it got there also needed to kind of be managed carefully. And so kind of stitching that solution together, if you're familiar with the construction industry, it's not usually one entity that kind of does a lot of the work. It's usually like a conglomerate or subcontracting kind of efforts and activity that happen. And basically through that process, it has many different players that are involved, and that kind of adds a little bit of the complexity, is how do you actually kind of manage all of those different stakeholders. Single source of truth for all those stakeholders is also a kind of big point. Obviously the state government who is funding the project has key kind of vested interests in making sure that the project is successful, but also that the project is kind of compliant. And so again, another kind of output in terms of, or stakeholder that we need to think about from a reporting perspective. So many different people were involved. We kind of got involved through, as I mentioned, discussions initially with Christian and Alice to understand the needs of the customer. And, one of the things that they had as an option was basically to use their existing tooling, which to some extent was obviously Excel. So, they had that as an option to actually kind of try to manage the different data points that were coming through. But aside from that, they actually had data capturing devices across all the different parts of the life cycle, which we'll kind of talk about. And so we were kind of involved from a hardware perspective, but our job was to actually think about how do we actually stitch all of those different data points together, and where there are gaps in how they capture data as part of that kind of discovery process. How do we actually then build other parts of the solution that then kind of help to bring all of the data points together? So thinking about, for example, when they do soil sample testing and the labs actually get the results, how's that fed back into the process? So all of those things were basically things that we need to kind of think about. So part of that was then for us to understand the requirements, work out then, what bit of a gap analysis, what was missing, what needed to be built. And then obviously as part of that process, then, build a solution as well. And probably the last thing I'll kind of touch on before I jump to this slide is massive project. So I think if you ever look up construction projects, they're kind of classified as, big build projects. This is one of them. So I think there's probably 8 or 9 big build projects that are done or being done at the moment in the country. And this is one of them. So obviously, again, from number of stakeholders involved, the complexity of, what needed to kind of be managed, the amount of money that was in it, and obviously any delays and the impact that those delays would have, both either from, construction build perspective, but also cost savings perspective as well. So all of those things needed to kind of be factored into all of that stuff. I think I've touched on most of the points around who we are. I think probably the only other couple of points from our perspective is we are ISO 27001 certified, which basically means, we've got a standard around, or we aim to meet that standard around data management, data protection, data governance, as well as we've kind of been classified top 3 Fast 50 in the CRN. So that kind of tracks technology companies in Australia, and the fastest 50 of them are actually classified in this and win that award. We've been the 3-time running award winner in that, so been in the top 50 for the last 3 years. Great place to work certified, and I mentioned we're a Microsoft shop, so we predominantly focus on the Microsoft and Databricks stack. But in terms of, I guess, our capability, we focus it not just on Power BI, but we also think about things like Power Apps, Power Automate, as well as the backend infrastructure, so integrations across Azure into obviously the data points and everything else. So a little bit about us, Westgate Tunnel. So I mentioned a little bit of information around that. Obviously started, or our engagement with the Westgate Tunnel project actually started in October 2021. So several years ago now, and it's actually only just ended. So we've ended up closing that engagement in July, I would say. So our work across that has basically completed. Doesn't mean that the project's finished, so it's continued on from there. So, but the point that we were engaged with around understanding soil and spoil management and the results and all of those things only was relevant, obviously, whilst the TBM was thank you, someone's just muted that person, was active. So that's now TBMs have basically stopped running, so tunnel boring machines, and so that part of the project is ceased, and so we've disengaged from the project from that perspective. But yeah, I guess beyond that, just probably the main thing is that this was a compliance project. We were actually engaged to help kind of manage, the soil and spoil tracking around contamination results, and where that soil and spoil actually needed to then be the ultimate kind of resting point. So could it be dumped, just in a general dumping location, or did it actually need to be kind of contained in a quarantine site? So that was basically why we were engaged, was to actually build a solution that kind of stitched together how all of that kind of fed together. Massive project, as I've mentioned. So I think all up probably in the billions of dollars. I think one of the projects probably done, I probably can't forecast, but I think at the moment it's spent about $8 billion to get to this point, and still probably got a little ways to go to kind of finalize that project as well. And so from our perspective, we had to kind of stitch together all the different stakeholders. So Westgate Tunnel project was actually a joint venture between John Holland and CPB, and had a number of subcontractors that were actually involved as well. So we had to basically think of that entire audience to kind of build together the solution. So I think in terms of my bit, that's probably it. Marie, do you want to take the next bit of it?
Yeah, sure. Thanks, Matt. So yeah, as Matt mentioned, I have been the project manager on this project. So I've gone through various complexities in getting to the point of building a solution to manage efficiencies, get over the manual bits and pieces from Westgate Tunnel. And on a holistic view, what I'm sharing on my screen at this point in time is Westgate Tunnel operations. Overall, it looked very simple. Before Rohan gets into the actual reporting solution build, I thought I might just give an overview of what actually happens on the operations. Those who've worked in construction industry or are familiar with construction industry would know that there are TBMs on this project. There were 2 TBMs. So we were looking at TBM 1, TBM 2, which were the tunnel boring machines. And the tunnel boring machines, they take out the soil and leave it on the shed. In the shed, the soil was actually saved there for some time before it was sent via trucks to the actual site. While being collected in the shed, there were soil samples collected for testing. This was the compliance bit that Matt just touched on. It was very necessary that the soil was actually tested before it can be disposed of. And there was a time frame of about 21 days from the time the soil was collected to the results were received from the lab. And at the same time, the trucks were actually taking the soil from the sheds and transferring them over to the actual site. There was a facility used where these soil was actually saved for some time. By the time the test results were received, these were then emptied over and disposed of to a final site based on the test results received. So holistically, it looked very simple, but there were quite a few entities involved. There was a system here which we were able to connect to at the TBM end, which was called the Heron Connect system. There were pivot sheds, and again, sampling was we developed the Power Platform apps for sampling at the stage, which were actually collecting the data for the sample results, and the samples were actually sent from the app as well to there was an automated email sent to the lab. When the lab results were received, they were also automatically ingested into the data warehouse, from where we actually saw what the results were, and people were able to monitor it for operational purposes, just to make sure they are compliant and they are able to report back to the EPA about the test results as well. At the same time, another entity involved in filling the trucks and taking it to the facility, which was another entity. And from there on, once the trucks had emptied at the facility, they go back to the actual shed to fill the trucks again and come back to the facility again. So this process continued. A lot of data touch points here, which we had to ingest and collaborate as part of this project. On a high level...
Sorry, I'm ready for you just to go back to that previous slide. So again, to kind of touch on Amrit's point around the complexity. No?
Sorry.
No worries, all good. I think up to 100 trucks, the entire operation was also 24/7, so never stopped as well. So, obviously the solution needed to kind of be maintained and managed and online for that entire period. And I think beyond that, how many entities were involved in Amrit, just off the top of your head?
Yeah, there were 3 to 4 entities, so different people and different data points and different people monitoring the reports. We had to set the reports in a way not everyone needed access to all the information. So some of it was just for internal Westgate purposes, but the other information was available to second entities. So even when developing the reporting solution, we had to define the workspaces differently for access by different entities.
Beautiful. Christian, I know there's some questions. Should we answer them as we go or leave them till the end?
Yeah, if you're comfortable just answering maybe Claire's question, Matt or Amrit, that's just in the chat. Sorry, the question was, Claire, how was the soil sample collected and the data inputted? So was there a manual process there? And then the follow-on question was, can you explain data governance around the data input and verification?
So I can take that. Yeah. So the soil samples, so there were soil samplers in the field. We built an app for them to collect the soil sample. They would actually they'll take their iPad, go into the shed. They would actually physically collect the sample, but they would take a photo through the app. And that way app will automatically assign like a sample code to whatever sample was selected. The photo gets attached to it. And then via the app itself, they could say, send it to the lab. The lab will receive a notification that there is a sample coming through, but at the same time, someone in the shed was actually physically taking those samples to the lab as well for testing. But at the same time, there was no point, like with the ingestion of the app into the process, the lab couldn't have missed the samples received by them. So every sample that was collected, there was a notification sent to the lab. Someone was actually physically transferring the sample anyways to them to monitor those and test those. So in terms of the data governance about data input and verification, so the way they were actually looking at or taking as everything was ingested through the app, so everything, all the samples as they were taken were recorded in the backend database anyways. And when lab has the results, lab get the notification that these are the number of samples. When they actually physically get the sample, they actually refer back and can tick across the lab, the sample codes, and can make sure that everything that they have received was actually sent through via the app. I hope that answers
maybe
the
I'll
question.
I'll add to that point as well. So all of the TBMs, so both TBMs had geospatial tracking tags that were on them. So Emery touched on the fact that there was a system called Heron Connect, which basically gave almost real time, the position of the TBMs. Obviously speed data as well could be inferred from that, like obviously if they're moving. And then obviously the trucks, we had, I think, 2 position data points, so weight and position when they swiped out of one location, as well as weight and location again when they swiped into the next facility as well, was being tracked.
No, that's great. Yeah, like I think it's very, very rigorous and robust sort of process in terms of data collection as it needs to be, and then the different sample points that you guys have sort of described there. That almost, they call it the chain of custody. So sample points to the lab, and then there's that full transparency of tracking of what those samples are. Just while you're on this point, I think Claire's asking a lot of really good questions. They're all kind of related. Just if you don't mind, and then we can continue the presentation. But I think this is a good point. How did you geotab the location point with the TBM? So how were the samples sort of related back to where that TBM was positioned at that time?
Yeah, that's been, so this has been a tricky challenge for the project. I don't know if Eddie is on the call.
Oh, yes. Yeah, I think I might be able to talk to it at a high level. We probably can't tell you the secret sauce, because that obviously is probably the nuts and bolts of how the system's kind of constructed. But effectively, obviously the position of the TBM and where it's at and was being tracked to then obviously the soil sample that was being taken, so we could kind of then link those 2 results together. There was a delay input that was also then input as a kind of override into the system, which basically said how long is it taking for the trucks to actually take that soil from when it actually gets to the shed. And then obviously the truck swipe in, swipe out results, weight results at both points. And then obviously the holding site is then the last kind of marker as well. So, all of that kind of end-to-end process was being tracked, not just from the data points that were being fed from the devices on the different machines and stuff, but also through the input solution that we basically built.
There was a time factor taken into account as well when the samples were taken, and where the TBM was. So we used logic apps in the background as well to build some of the solution.
Fantastic. No, thanks for addressing those just as we go. There are some others, I've noted them down, but if you want to continue, Amrit, and then we'll touch on them later in the project. No, great questions, everyone. Thank you.
Yeah, cool. No, from a project requirement perspective, we've touched quite a bit on this. I won't spend too much time on this one, but there was an application integration which required sample collection as well. And there was another app developed as part of this project, which was a waste categorization app. And we also developed some workflows for approval but in between entities. Data management was obviously a key part, connecting to different sources of data. we built a data warehouse and data was modeled. We had logic apps to ensure we can answer some of the business processes, and built in some logics for the accuracy of information. The final end product, obviously BI and reporting, mainly operational management, make sure the key stakeholders had visibility to the spoil transfer, how much was getting transferred from one point to another, and risk management. Obviously, there was a 21-day compliance that everyone had to follow as the test results were done. That was a key portion of the operational management, along with test results reporting how the test coming out, as well as the base status, which is where the facility was, which is where the soil was actually getting stored in the facility before it was disposed of. So yeah, those were the key requirements on the project. I'll probably hand over to Rohan to go through the actual Power BI reporting solution that was built and the most exciting part of the project.
Yeah, before we jump into that, sorry if we just jump back one slide again. So probably the only other constraint that we had was the holding site. Obviously, the soil needed to kind of be transferred all the way across, kind of end to end, and then put into its final resting place, quote unquote. But it basically, you know, we had a limit in terms of the number of sites or the number of holding bays that the soil could be kind of contained in. So obviously, any delays in the process actually would result in the project actually stopping as well. So, you know, that flow of soil actually needed to kind of be continual and consistent, as well as, you know, if there were any delays, we needed to kind of flag that through the reporting solution that was built. You know, if there was timelines around when all of the key processes and steps actually needed to be done or achieved, if anything was actually not hit to that timeline or was at risk, then it would be flagged up to management for them to review. And so I think the biggest thing as well around it was that all of this process needed to be compliant, but it also needed to manage to the time and space constraints that were kind of existing. So, you know, obviously, I think if loosely that this number was quoted to me that for every hour the project actually was delayed, I can't remember if it was hour or day, but let's say it's day, then it was minimum of a house was cost of the project. So effectively, like any delay was at least $1 million lost in the process. And so, you know, that again was another constraint that, you know, we needed to make sure that all of these kind of compliance requirements were met, but then that there was always this seamless flow of kind of information that made sure that the operation could continue nonstop. Cool. All right. Over to Rohan.
Thank you, Matt. Thank you, Amrit. So I think I'll take over the screen now, Amrit, so that I can give the demo.
Yeah.
So
sure.
This actually was my first project with Agile. So this is a really special one to me. And I got a chance to work with some amazingly talented people over here on this project. And the scope of this project was vast. Like there were just so many elements involved in this. There were Power Apps, there were data warehousing, there was compliance, there were data analytics, reporting. So just for the purpose of this particular meetup, we'll focus on the Power BI aspects of it, but there's definitely more to it at the back end that has gone in there. So before I start with the demo, I'll quickly like to show you the backend architecture, just for you guys to get an idea of what were the data points and how the report has come into place. So are you guys able to see my screen?
Yeah.
Okay.
Yeah, okay.
So these were the key data points. So as Amrit and Matt mentioned, there were just so many different touch points from where the data was collected. So we were getting data from APIs. So Heron Connect was the API that was sending the data for the TBMs, so like what was the speed, what is the position, and then there was APIs from Mandalay, which was the holding base site, and the way bridges, and then there were data coming from Gendio, which was sensors from the trucks. Then there were data received from the labs, which were CSV file, which were processed. Then there was a Power App, which was designed by Agile, and that was also collecting data. And all this was fed into Azure SQL DB, and that was the source for the Power BI reports that we developed. So I'll move over to the Power BI report. All right. So as Matt mentioned, like the tunneling process is now complete. So what you will see on the report is, if you see like the last was updated on 30th, but we have the report and I will walk you through the different aspects of the report. What are the touch points in here, how the report was being used, and I'll go through each of the report pages. So this particular page was an overview page. So this was like the landing page. This would give every day the real-time status of where the tunnel is, what is the speed of the tunnel, how much spoil has been removed, and what is the current domain, ring code. So the exact position of the tunnel could be tracked. So we had the latitudes and longitudes of all the position of the tunnel. And as and how it progressed, it went from gray to green, and we could see in real time how it was being completed. And there were two tunnels. One was the inbound and one was the outbound. So we could track both of them at the same time. And over here, what we could see was this is the progress of how the tunnel was progressing and what was the change and at what speed it was being it went ahead. And then at each of the chainage or location, how many samples had been collected? What were the samples being collected? Because that was the key aspect of this project. Wanted to identify the were there any high contaminated soil or any other chemicals. So sampling was essential, and to identify those samples, we made it quite easy. Like they could quickly select a particular domain that they wanted to focus on, and in that domain, if there were any samples or let me just select this. So we can see that on this particular domain, this was the area, and how many samples were collected on this particular day. And if I want to get a detail of those samples, I can just simply drill through and get all the details of those samples. So it
I
was
think
very
probably the
transparent.
terminology, sorry, Ron, I don't know if everyone's across what
Yeah.
domain means, but domain was basically kind of a geographical area which like where the soil was of some consistency. So obviously, you know, each domain was defined based on like what were the chemical composition of that area, but also, you know, obviously what was it made of? Was it soil or something else?
Yeah. And as you can see over here, we can get all the details over here. What was the sample ID? What was the sample code? And who actually took that sample? So all the details were recorded over here, and they could easily track if there were any questions or if they wanted to validate any data. They had everything in place over here. So this was from an overview perspective of how the tunnel is progressing. Now, the next part was, as Amrit mentioned, like, let me just bring this up. Like this was the process. So this was the tunnel boring machine. And from this machine, the soil was using conveyor belt. It was brought up and it was stored in this pivot shed where sampling was also conducted. And then from this shed, it was filled into the trucks. It was fully covered trucks. And from here, it was taken to the disposal facility, which was the high Q site. So managing these trucks was very essential. They had to ensure that the trucks are following all the protocols. There is less spillage of the uh, soil from the trucks. The trucks are on time. So that's why we had a page created specifically for the transportation. So which could track all the movements of the trucks. So in here, what we could see was for the period that we have selected, how many trucks have passed through, like what was the average trips per day. So they had SLAs for each of these different conditions, like they had to maintain certain criteria, average trips per day, what was the current position of the tunnel, then what was the weight at the pivot site and what was the weight at the final BSF site, which was where the soil holding base basically. So making sure that the variance was minimal so that there's less spillage was the key criteria that they wanted to monitor. And so over here, we can see how many trips each of the driver has made. I can select a particular driver and I can find out how many trips he has made per day so that if there is a particular driver who's performing really good, or if a driver is performing really poorly, they can track using this particular report. And even so, this is like a quick chart view, and then we can get a table view, which will show the details of each of the journey. So we were monitoring every single aspect of it, like how long did it take for the driver to grow from the pivot side to the high Q side? How long did it take for it to go from the final bay side within the bay side to the holding bay? Because there were way bridges, so they had to pass through that. And then how long did it take for it to come back to the pivot side? So every single journey was tracked, and they were KPIs for that, like whether it was on time, whether it was late. So we could see that if it has gone red, that means there might have been some problem. And if consistently, if a particular driver is delaying the journey, then obviously he has to be informed or some changes need to have been made. And then we have a breakdown by each of the journey. So pivot departure to high Q entry. So we can see maximum was like 90 minutes, like that's the red zone. It shouldn't go above that. And this is like the average. So this helped them to track the truck performance, and we could see if there were any anomalies. So this was pivot departure to high Q entry, then high Q entry to high Q departure, and then high Q departure to pivot. And then we could quickly track which were the journeys that were more than 90 minutes, which were the journey that took between 60 to 90 minutes. And they could track almost all the details of it. And like I mentioned, like another part was weight variance. So time variance was also critical. Then weight variance was also an important aspect, so that to ensure that there was less spillage of soil. So this was another tabular report which they wanted to maintain for the truck performance. So and these KPIs were all real time. So at the moment, since we do not have any live data coming through, we are seeing 0. But it would highlight if there are trucks being delayed more than 90 minutes, if there are trucks delayed between 60 to 90, if there are overweight or underweight trucks. And we can identify them quickly over here. And we can see which bay it is going to. So the trucks are assigned a particular bay, and they have to ensure that they go over there and drop the soil over there. And we have quick filters to specifically search by a particular truck number or even by a driver's name. So this was like the journey of the truck from from the pivot to high Q side. And now what happens is at the high Q side, which is the holding bay status. So this particular report was very useful to track which bay is filled, which bay is empty, which bay is being maintained under maintenance, and which bay is closed. So at the moment, again, like this report was a real-time report which would show the status every day. And since at the moment everything is closed, we can see it as closed. But few months back, if we would have looked at it, we would have seen different colors of dots. So we have statuses like it is available, it is being filled, it is full, being emptied, closed, or under maintenance. So this gave them an idea of, okay, which bay should we allocate next? How do we track it? Is a particular bay taking too long to be filled? And each of the steps have been recorded in this particular table over here. So what we can see is, let's say if I take a particular bay range, if I take bay range B, then I can see when was the first truck entry over here on this particular B3.03. So when did the first truck come in and drop the soil in here? And when was the last truck? So it took about 2 days. So 3 days to be 3 complete days. And then how much spoil has been filled into this? And they had to ensure that all the protocols were followed. Like they had to ensure that images have been uploaded. They had to mention that the wastecat report has been accepted. Only then can the bay be emptied, because then that bay can be cleaned, can be washed, and then it can be used again for the next batch. So we can see on the tooltip over here when it was accepted by the JV, which was one of the organization, and when it was accepted by HiQ. So all the information, we could track it in one go. And as Amrit mentioned, that they had a 21-day turnaround. That 21-day turnaround was so crucial that they had to follow each and every step in a specified timeline. And they monitored this every day. So they had a base target and they had a final target. So base target was like, it's if we finish it on or before this, we are on track. But if we go extend this, that's when things are going to get delayed and that's when costs are going to start increasing. So these flags help them to track each and every process and to ensure all the steps have been completed. Now we can see what we are seeing over here is the real-time information. But if I want to see historically, the historical information of the base, we were recording and storing that as well. So if I go to the historical information, and let's say if I just select a particular date range, I start from 1st of Jan, yeah, then we can see which was the bay that took the longest for filling. So then we can investigate what took so long, what happened over here, what went wrong, and then we can track like is that the trend for all the other bays as well. Like most of the bays have been filled in either 2 or 3 days, when what took so long for this. So that can be investigated, and we can track each of the bays, when was the entry date and the spoil, and we could track the SLAs also for it. So all the different stages, like for this particular bay, it was available. It was available on this. It started being filled on this date. It was full on this date, being emptied. So all the dates were recorded and maintained. And then based on that, these were their SLAs, like number of days. It should be accepted within 4 days, or it should be accepted within 25 days. So if it was red, obviously that was a problem. So once we started implementing it, things actually started to, the KPI started to improve, and the number of days it was taking, it started to reduce. So which was a really good sign. And then this was another view which we provided to just visually see which bay is being emptied, which bay is available. Is it available for a very long time? Is it under maintenance for a very long time? So these were the kind of reports that we were tracking. Now, I'll go into more detail about this 21-day turnaround report. So this, even though it looks like a tabular report, but there's just so much logic that goes on behind this, and then so many um, metrics that are calculated over here. So if you see, these were the steps that they had to follow. Like first, the COC has to be sent to the lab, then the sample receipt notice, they receive it. So as and when, these are the steps. And as and when it proceeded, the dates were being populated. And if you see over here, we can see when this process was completed, what is the target date of completion, and when is the last acceptable date. So at the moment, since all the processes are completed, we can see all the blocks being completed. But if few months back, if we would have looked at if this was the bay that is currently being filled or work is being going on, then let's say if it is at a laboratory data receive stage, then I would hover over here. I can see, okay, it was completed on 31st March, and before 7th of April, I need to complete the next step. So if it passes 7th of April, all this would have gone in red. Even though there were no dates, it would have highlighted the users that this process needs attention. You need to complete this process on track, follow up with the people, and then get on top of that. So that's the information that we were giving through this. And this was just a summary of how many days are left for each of the bays to complete the final stage. And like this was the real-time information, but we even gave them the trends. So to find out the trend of how the performance, whether it was improving, whether it was going bad. So what we can see over here is the trend for that, basically the month-on-month trend for the number of days it took. And at each stage, like how long it took for the COC sent to lab till the data was received, how long it took for the lab data received by WCR to accepted by JV. So every single date timestamp and the trend was being tracked, and this helped them to improve their processes and help them to get things done on time. So this was the 21-day turnaround report. And these filters also help them to quickly, if they wanted to look for a specific tunnel, only for AB, only for Bay Range D, they could use these filters and quickly get information that they wanted. And one of the last, but the most important report was about the test results. Like as Matt mentioned, like being compliant was one of the key aspect, and they had to follow the norms of EPA, and they had to maintain complete transparency about what the tests were being carried out, what the results were, and one of the key element that needed to be tracked was the amount of PFAS in the soil. Like it was known that since it was built on top of an industrial area, there might be some PFAS in there. But was it above the recommended uh, quantity? That was the crucial part of the report. So they needed to track that. So all the testing that the lab had conducted, all the results were being tracked over here, and then they could quickly see between a date range for a particular, let's say for a domain, within a domain, if there were any samples collected, or how many out of those samples, how many were defects, what was the maximum result, and what was the average result. So if I see over here, I can see that these 4 samples had uh, the results were above the limit. So that's why they were termed as defects. So they have the transparency to see it over here. And similar, like take a table view, we have even given them a chart view and a trend view for it, so that they can track whether there have been more and more uh, defects in a particular domain, in a particular chainage. So that's how things were being tracked over here. So I think pretty much I've covered all the aspects of the report. But yeah, like I said, like the report, we tried to keep it simple but informative, so that the main purpose was to have complete transparency and to identify the key blockers and the block points. So that's how we had achieved this, and the stakeholders really, they use it every day and it helped them a lot. So yeah, that was the journey of this project. So I'll hand it over to Matt. Yeah.
Yeah, no worries. I think, we'll probably answer any questions. Obviously, you kind of now get a sense of the complexity, the number of things that were being tracked all at once. Obviously, this is a live project, so I think most of these data points were live to within what was the lower limit of it. Do you guys know?
30th of June was when they last received the data.
So sorry, I meant within when that data point was captured. How quickly were we then pulling them?
So which data point are you referring to, Matt?
So maybe the Heron Connect results. How accurate, or sorry, how live were they? Sorry, I should say.
Yeah, 1 to 2 hours. Every 1 to 2 hours, we were just connecting and pulling where the TBM was.
Yeah, and so I think that would have been probably reflected across most of the other data points that we mentioned as well. Obviously, the apps, they were real time. So obviously, as the data was being fed through, they were coming through in real time. And I think the lab results, the same thing. So in real time, obviously, as the lab results came through. So again, once you've seen how the solution was put together, there could have been no other way for it to kind of be constructed. Like it wouldn't have been the solution, or the project wouldn't have been able to be kind of managed in a manual fashion, as was kind of initially thought. And I think probably a couple of other points. So the EPA actually reviewed parts or all of the solution, and Vic EPA, I should say. And so they actually kind of labeled it as the gold standard for which future soil or spoil tracking projects should actually be managed and maintained. And in fact, the joint venture, John Holland and CPB, now actually use this solution in all of their tenders. So if they're bidding for new or new pieces of work, they're actually using this solution to kind of, I guess, not register, but to kind of show their capability in this space. Everyone So all of the different construction companies can actually build the solution, but how you actually track all of this information is kind of a key differentiator for businesses now.
Fantastic, fantastic presentation, guys, and yeah, thanks so much to Amrit, Matt, and Rowan for the excellent session. I think Alice commented in the chat, it's a fantastic solution. It was like it covered. I know it was a fair big process, probably a lot of learning and understanding from your perspective, as well as like educating your clients and stakeholders along the way. But no, fantastic sort of solution. That's great. Look, we did have a few questions. This is the point. I think there's Claire Lang. Claire, if you're still online, you're more than welcome to come off mute and ask your questions directly of the guys now that we've sort of finished the formal presentation session. So feel free if you want. Otherwise, I can communicate your questions. Okay, I might just ask a few questions that I did see in the chat. Okay, mic's not working. No worries, that's cool. I'll see if I can get these out. And then if we don't get to all the questions in the last 10 minutes, Matt, Amrit, are you okay if I sort of include them in an email and we can include them in the blog?
That's cool.
So I think you touched on this, Rowan, but were the trucks being tracked? Do you want to just explain a little bit about that?
Yeah, they were being tracked. So there was something called a weigh bridge, which basically weighed all of the trucks going out of one site and into the other site. So there was two weigh bridges and a fob, which basically every truck driver had. So they were actually then swiping in and out. It was tagged to them as the driver. So then we could kind of track both the exit and entry on the other side as well. So we were then tracking the weight of the truck when it left one side to the weight of the truck when it entered another side. Through that process, like there was identified some issues that, potentially some soil was missed or spilled, and obviously tracking in real time. So then we could actually then see if there was a potential issue that needed to be reported and some kind of corrective action actually taken as well. So trucks had that as an input. There was a system that Amrit mentioned, which was called Mandalay. So Mandalay obviously took in the weighbridge information, but it also had information around where the soil was actually being stored in terms of those 58 bays that Rowan was just showing on in one of the reports. And then obviously the status of the bays as well was tracked through Mandalay as well. So again, lots of different data sources to kind of ingest, and each of them had some complexity in terms of what the data quality and all the other things that needed to kind of be factored in. Perfect.
No, I could imagine. I mean, when you put up the data architecture sort of diagram, Rowan, I mean, there's this API, this API, this API, this sort of piece of data coming in. So I know there's a lot of challenges. Similar sort of question. Someone wrote in: were there QR codes or a method of automatically scanning or labeling the bins and the samples, or how was that more through the app entered?
It was through the app. Yeah, it was through the app. So they were not QR. This was talked about in the project to get some QR codes done, things like that. But I think as an eventually the solution was just through the app. The samplers were taking these samples and then scanning the photos. So that ways they would know that this specific sample belongs to the photo taken, and to keep it aligned. But QR code was brought up at some point in time, but I think we never got done that part. But would have been great if we could do something with the QR codes.
Yeah, but like you said with the apps, I mean, you can bring in your own sort of data validation components to that as well, and then couple it with those photos, which can be so helpful a few weeks down the track, or in your case, a few days down the track. So it's excellent. Thank you. Just a few more. I think this one was covered off, but someone asked did the truck drivers input into the Power App? Based on what you've said, is that a no because the trucks will automatically?
Yeah. So their fault. There was the thing that was kind of local to them. So obviously everyone had their own unique fob that they would swipe in and swipe out.
Perfect. No, that's good. And I think just were there automated alerts set up for the project teams in relation to if thresholds were exceeded or different things?
No, the way the project was working, the report was refreshed like 8 times a day. So the whole project team were on it daily to monitor the progress. So if anything hasn't come through or has fallen off, it would actually show in their daily report whenever they look at the report. So yeah, we didn't get down to the path of setting down alerts because there were quite a few people who needed to manage the whole of operations in the team, just to make sure, for example, if the lab hasn't sent the results, there was a separate person who was taking the ownership to follow up with the labs. But if there was any other delays or anything like that, there could be other people looking after it. So that's why this operational report was quite handy for the whole of operations to monitor where things were in the process once the samples were taken, and if we were on track to meet the 21-day compliance.
Yeah, and I think imagine it like a control room question. So I think obviously these reports would have been basically the source of truth for all of these things. Doesn't mean that alerts or some of those other solutions couldn't have been implemented. Business decided obviously that they didn't want to go down that track, more from like I think a complexity and management perspective.
Yeah, no, it's that makes perfect sense. All eyes on it. And this is the last question. There are, like I said, a few more that we can capture in the blog when the guys can get a chance to reply. But from me, just as an overview looking back, so what would you say were the biggest challenges, maybe one or two from a data management perspective on the project as a whole?
Yeah, one of these have been spoken about recently in terms of identifying and making sure the time the samples were taken could be aligned to where the TBM was taking the spoil out. So there were like connections to be made in terms of when the sample is taken, where was the TBM when the sample was taken, and how the trucks were actually taking that spoil, because we needed to link back that portion of the soil back to the TBM. So that has been a challenge, which was resolved through the project. Other challenges obviously has been in terms of getting to like even the 21-day report. When we started establishing the report, that was a challenge to see how we get because there were 2 or 3 different apps in the process from a data management point of view, and the way because the app was sending the information to the lab, and lab, when they do their test results, they send it through a different route via an email. So that whole process of management and setting up the data management to monitor end to end has been challenging, which was obviously evolved as we work through the project. I don't know, Rohan or Matt, if you've got any others.
Maybe one other from me is two actually. There was so having one source of truth, but then many different views, I think was also an important kind of requirement, because again, it wasn't one organization that was kind of dealing with this information. It was many different organizations, and all of them had to have some like their relevant part. So I think that was kind of not a challenge, but it was kind of a difficult part, was to actually then work out, well, what is the actual view that stakeholder actually needs to do their operational element. And I think probably the other thing is that the solution wasn't, so if you break this solution into different parts, it exists, right? But there is no one solution that actually kind of covers all of the different things that this system does. So I think in that way it was greenfields. And so, I think stitching it all together and making sure that it actually was working almost 100% of the time, obviously, because again, if it didn't, everything stops. And maintaining that, and then making sure that obviously it's compliant and all the other elements, that obviously was a critical challenge that we had to kind of work through.
Amazing. It's a great point. And I guess like it's testament to sort of the work of you guys at the end when you sort of say EPA, which is the regulatory body, sort of looks at this as that gold standard, and both John Holland and CDVG are sort of implementing it for future projects. So well done, Agile team, and thanks again for sort of being able to share those experiences and that knowledge in the session here today. Just to close out, there's sort of lots of nice comments coming through as well in terms of great solution, great work, and people really appreciative of your time in putting this together and sharing your thing. And we know we appreciate it as well. So thanks, guys, and fantastic job. On to September, which is we're over a week away. 14th of September, we've got our next session. It's called the Dredge Dash. So we're looking at dredging projects, real-time dredging project management tool, harnessing Power BI. So I guess similar to a degree as what the team has spoken about today, it's not just Power BI. There's a whole range of various, logic apps, SQL databases, things involved in this particular project, this time for an application to do with dredging off the coast as well, and a few different examples. But stay tuned for that come September. I'll announce that in the meetup group again soon. And also, if you wanted to rewatch or catch up on various elements of today's session, we'll make available the recording and blog by these different links. And also, always keen to get people involved in terms of presenting. So, new people, even if you're a beginner in Power BI, it's always nice just to hear different people's experiences and different examples. So please get in touch with me if you did want to present, or if you're interested in presenting either later in the year or, as time flies, nearly into 2024, so early next.
I think you're on mute.
Just put yourself on mute, Christian.
I don't know if it was me, if it was someone else. Am I back? I'm good.
You're back.
Just people are sick of my voice. We're nearly at the end, so yeah, thank you. Just mainly thank you to the Agile team, and thank you everyone for dialing in as well. Really appreciate it, and and enjoy the rest of your day. I do have to jump off. I apologise. We've gone a bit over time, but you'll get a notification when we put up the recording and the blog, hopefully by the end of the week. But yeah, lastly, thanks again, Rowan, Matt, and Amrit. Great session. Really appreciate it, and thanks everyone for dialing in.
Thank you.
Thanks, Kristen and Alice, for having us. Thanks, everyone. Yeah.